Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here at Douglas J. Miller Elementary School, home of the Mustangs, and we're here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Mary Lou.
And in studio with us right now we have Alyssa. And Alyssa, if somebody wanted to get a hold of us, what would they need to do?
For math homework, help call in Bakersfield 636-4357, toll free 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
That was well done. That's a mouthful, isn't it? A lot of stuff to get out there the first time. Why don't you let everybody know where you go to school and what grade you're in?
I go to Buena Vista Elementary School, and I am in 5th grade.
How's 5th grade going so far?
It's really good.
What's so good about it?
We're doing projects in school, like writing projects.
So you like doing that?
Yeah.
Good. All right. How's math going?
Really good.
Really good? All right. Well, you know what? Because you missed part of your regular class today because you were at another class and they started something new today, right?
Yeah.
And what was that?
It was multiplying and dividing a whole number by
another whole number? Larger number? Fractions? Decimals? Well, here's what we're going to do, because you know what you're going to do a lot of this year?
What?
Fractions. So we're going to start off with a little bit of a base on fractions right now, right? So why don't you head on over to the board with Mary Lou. We'll talk about just some of the vocabulary, the parts of a fraction, and taking like fractions and adding them first.
Okay, you ready? Okay, so we have this fraction. What is that fraction?
1/5.
1/5. Do you know what the top number is called on a fraction? It starts with an N. Have you heard it before? It's called I'm going to change our color real quick. It is called our numerator. Have you heard that term before?
Yeah.
Okay, if that's my numerator, that's my, starts with a D. Denominator. Hopefully I spelled those correctly.
You are correct.
Yes. So again, what's the top number?
Numerator.
And the bottom number is the?
Denominator.
Is the denominator. The fraction 1/5 means really, can you draw me a picture what 1/5 looks like? If you have this bar? Perfect. So it means we have 1 out of 5 pieces, right? Okay, so we have our numerator, we have our denominator. So our numerator is our part, okay? We call it our part. And our denominator is the?
Whole.
Very good. See, you knew that already, didn't you? So that's our part and that's our whole, okay? What if we were adding fractions? So if I have 1/5, give me another fraction that has 5 as a denominator.
3/5.
3/5, okay. So we have 1/5. We're going to make an equation out of this, plus 3/5. So using my green, okay, you've already shaded in 1/5, haven't you? Well, we're going to add another 3/5, okay? So if we add another 3/5, let's draw another box that's equivalent. And then I'm going to break it up into just like you did. Can you shade 3/5 for me? So if we have 1/5 and we're adding another 3/5, how many do we have shaded total boxes?
4,
We have 4 boxes out of
5.
5. Can you write that for me over here? Can you write the 4/5? There you go. So that's what's adding fractions. And this is what you're going to be doing a lot of this year and on into the future. So again, all we're doing is looking, if I have 1/5, I'm adding another 3/5, then we know that it's going to be 4/5. This is called like denominators because our denominator is exactly the same. Look at this. Can you tell me a strategy? Instead of having to use a picture, what do you notice about what's happening with that equation?
You just add the top, but you don't add the bottom.
Exactly, that's it. You just add the top numbers, but we're leaving the bottom numbers the same because our denominators are the same. Do you want us to go any further with
We're going to
that
stop
one?
there for a moment, and
Perfect.
we'll have Alyssa do a little bit more with that in just a few moments. Do remember we have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, and today's Math in the News, quite literally, taken out of today's sports page. So today's sport, did you read today's sports page in the newspaper? No, well, you know what? I had an opportunity to take a look at it. So, do you like watching sports or do you participate in any sports? No? All right. What about Mary Lou?
Oh, yes.
What do you have as a favorite? I know running is one of your favorite things
Yes,
to do, but
it
do you have a
is.
sport you like to watch
Soccer
or play?
and football.
Soccer and football.
Yes.
All right. Well, you know what? It is NBA season. So, in the news today, there was a story about a pretty famous basketball player, Steph Curry with the Golden State Warriors. Curry hopes to return from broken hand in early spring. So that means he's going to be out for quite a long
Yes,
time.
that is.
Now, I saw that and figured, all right, there is some math involved with Steph Curry. So we can see the NBA logo right there. And here's a little trivia question for you. Do you have any idea who this is modeled after? The NBA logo, the person that is modeled after?
It's not Michael Jordan.
No.
It's
Before his time.
It's before his time, and he's really, really tall. Yes.
Most of them are.
Yes,
but
he's really tall.
he played, he was associated with the Los Angeles Lakers.
Yes. I can't think of his name. Kareem.
We're going to,
Is it
no, we're going to give her a clue. New York is on the East Coast, but California is on the West Coast, right? Jerry West.
Oh.
So that, just a little bit of
Did not
trivia
know
right there.
that.
That's who that is modeled after. So, but Steph Curry is one of the more famous NBA players in the league and has been for quite some time. Has won a couple of titles, and I just thought that was a pretty cool
That is a cool
photograph.
picture.
You know what I mean? It's like a couple of them together. But I thought that was pretty cool. So, how are we going to tie this into math? So I found this article in a magazine, and we're just going to look at the bottom of it right now. The combined odds of each of these accomplishments. Now, first of all, the odds of scoring the most points in the NBA is 1 to 476. Right?
Okay.
If there's 476 players, you're going to score the most. The odds of having the most points is 1 in 476.
Okay.
So he did that one year. Okay?
Wow.
The odds of winning 2 MVP awards in a row is 1 to 1,904. And he did that winning his second MVP award the same year he had the most points in the NBA. Okay.
Impressive.
Now we take a look at the next one. The odds of having a 50-40-90 season, that's based on points, assists, rebounds, things like that. So the odds of having that are 1 in 1,254. So all of these happened the same time.
In the same year.
Right.
He had
So
a
now,
really good year.
let's take a look at this. The odds of all of that happening in the same season, 1 in 136,505,216. The odds of that happening all at once, and it happened
Wow.
for him. And there are a lot of other statistics and infographics and things like that based on Steph Curry. But I figured, all right, now let's take and apply a little math to this, how you find the odds. All right? So, probability and odds and probability. So, an example. So this is perfect that Alyssa's going to be working on this today. So the probability is 5 out of 13. So we know 5 would be the outcome that you want, and 13 are the total, that's the whole number of outcomes. So we can take 13 minus 5 are the unfavorable outcomes, because 5 are the favorable out of the 13. So the odds are 5 to 8 that something will happen. 5 good, 8 not good. All right? Everybody good?
Yes.
Okay. So now we'll go odds probability. So if somebody says the odds are 9 to 21, you want to know what the probability is. Well, you have 9 to 21, so you know there are 30 total outcomes. Because we have 9 good, 21 bad, right?
Right.
Total number of outcomes is 30. The ones you want are 9 out of 30. You can simplify that to become 3 out of 10, which is 30%. That is the probability.
Yeah.
And that is today's Math in the News. I just found that astounding.
That is really cool.
All of the things that Steph Curry was able to accomplish in one season and the odds of it happening.
Yeah.
And there were things, I think there's one more on here. Well, there's a lot. But where he shoots the three-pointers from, because he shoots a lot of three-pointers.
Probably is consistent with that.
But he's a lot farther back than where a lot of other NBA players shoot their free throw or three-pointers from. But anyway, that's today's Math in the News. Now you know a little bit about basketball and probability and odds, huh? You ready to do some more work?
Yeah.
All right, so let's head back over to the board. So the first one you had up there was 1/5 plus 3/5. And you knew that with the common denominator, you had 4/5. Okay? So now what I'd like you to do is I'd like you to go on. Now you can decide, do you want to keep the 1/5 or the 3/5?
Which fractions
Which
do
would
you
you
want
like
to
to
hold
keep?
on to? The 3/5?
The 3/5?
Okay.
All right. So make some more room. So we're going to have 3/5.
Right, 3/5.
Now what I'd like you to do is add to that 1/10. Now you and Mary Lou go ahead and figure out what you're going to do with that.
Okay, so remember your strategy over here? You said, well, all you do is what?
You add the numerator, but you don't change the denominator.
Right, and is our denominators the same here?
Yes.
Yes, it is. But here, is our denominators the same?
No.
No, so we can't add our numerators just yet because we need the denominators exactly the same. Okay, so I'm going to show you a picture. And this time, again, I'm trying to think, we have 10. So let's see how we're going to do this. Break this into 5, just like you did. And how many do you need to shade?
3.
Okay. So over here, I'm now going to break this box not into 5s, but into
10.
Into 10s. So let's see if I can get this. How many lines do I need?
9.
6, 7. And we're going to have to go up. 8. And do I have 10 boxes? Count.
It's going to work.
Did I get 10?
Yeah.
I got 10 here. How many are we going to shade?
1.
Okay, shade 1. Okay. So here we have 5, we have 10 here, okay? What we can do is this. Does 5 go into 10?
Yes.
It does, doesn't it? So how can I make this an equivalent fraction to make this out of 10?
Multiply it by 2.
Very good. I have to multiply it by 2. So if we're multiplying this by 2, am I multiplying both numerator and denominator by 2?
Yes.
Okay, yeah, because what I do to the bottom, I have to do to the top. So what's your new fraction? Let's put this right here. 3/5, and we're timesing by 2 and timesing by 2. What does that equal? Six tenths. Okay. We need to break that into 6/10, don't we? So we're going to take this 3/5 and we're going to break into 6/10, but our box is kind of small. Okay. So
what
we
you
want
could do is you could just draw a line right across the middle of it.
Can we draw there? Oh, there we go. Boom. Do we have 10 pieces now?
Yes.
We do. So how many boxes are shaded?
6.
Yep, we have 1, 2, 3, 4, 5, 6. So here we have 6/10, and we're adding another
1/10.
1/10. What's our final answer?
7/10.
There you go.
Nicely
So-
done. So a little bit of work right there
Yeah.
on the getting the denominators the same when you have two of them different, and how you can go from the 5 to the 10. We'll continue
Yes.
to work a little bit more with that with Alyssa right here. But first, we have an opportunity to head on out to Miller and check in with the Mustangs.
Hey, we are here at Douglas J. Miller Elementary School, and we're here, the home of the Mustangs. These Mustangs are ready to do some math. So we have everyone prepared with a whiteboard. We got everybody with a pen. We got everybody with an eraser, and they're ready to go. Show me how to do this problem. We were talking a little bit earlier about how to multiply and divide some big numbers. And so let's see if that paid off. 75.4, and I want you to multiply this times 1,000. 75.4 times 1,000. Show me what you got on that one. We got a crew over here. See if we can explain this. Trinity, what's going on here? How'd you do this problem?
You showed us the way how to move the decimal over how many times was in 100, which is 2 zeros.
Oh, gotcha. Yeah, so 100. Now, what was it? Did the problem have 100 in it, or did it have 1,000 in it?
Oh, 1,000.
It had 1,000 in it, didn't it? It's important to know how many zeros there are. Yeah, that's it. People around you agree?
Yes.
Andrew, you agree with this one? Yeah. Okay, so what's your final answer after you get done with this whole thing here?
So, 75.4 times 1,000.
Mm-hmm.
I just moved the decimal from here 3 times, so 1, 2, 3. And right here it was blank, so you need to add 2 zeros. And then you got 754,000.
Oh, try again. We'll put the comma right there. You got the right number. Just got to make sure that comma's in the right place, right? I really like how you said this. Now, see if you can answer me this question. Think about it before you answer, okay? We were multiplying times 1,000, which has 3 zeros. But the answer you got only has 2 zeros, right, Raylene? It only has 2. Why is that? Why do we multiply times 1,000 with 3 zeros, but the answer only has 2? Nicholas, you have an answer about that? Why is that the case? I like it. You did it the long way, right? You worked it all out, and you still got the same answer we did. So I like the fact that you kind of proved you can either do it a fast way by moving the decimal, or you can do it the long way, right? I'll even throw a comma in there for you. But why are we multiplying times 1,000 with 3 zeros, and your answer only has 2?
Because you multiply the 4 and then you go straight, and then you add a 0, and then the next one with 0 you add 2 zeros, and then the next 0 I add 3 zeros, and then I added, but then the 4 was there at the end on the first one, and then it gave me that answer.
So you had some space holders there too, huh?
But then at the end there's a decimal right there, so what that is, the decimal behind it is the 4, so the decimal is by moving back 1 space, so this one I put it moved back to 1 here.
It is, yeah. I like the way with this longer way of multiplying. That's exactly right. You had 3 zeros, you had them, but you had to move this decimal back 1 place because of the decimal in the problem. Good explanation. I like it. Who did it the way where you had to move the decimal over? Okay, and we want to know why you only have 2 zeros over here. What do you think? How come we only have 2 zeros?
It's because when we multiplied it by 1,000,
Yeah.
there's 3 zeros. And
There
when
are
we-
3 zeros, right?
And the decimal was at the, you know, it
Between
was
the
at
five
the
and the
second.
four,
It was
right?
at the between the 5 and the 4.
Right.
Then we moved it once, and that took up 1 space, and it was after the 4 at that. So then we had to move it twice more, which we had to put 2 zeros.
I like how you explained that. That's excellent. Yeah, you had to go past the 4 first, and then 2 more spaces, and there's your 3 zeros. As you moved it 3 times, right? That's it, exactly. All right, if you want to erase that part, I want you to do at least one more, because this is good times. You can't get away from the fun we're having here. Interesting problem that we have here is 0.27. Oops, we're not going to multiply this time. This time I want you to go the other direction. Divide this one by 100. See what happens there. 0.27 divided by 100, and we will see if we can hang out with this crew over here. Jack, what do you got, man? Where's your final answer?
I got haven't done it yet. Okay, so 0.27.
He's moving it. All right.
Okay.
All right, here we go the long way too.
0, 0.
Where's that decimal? Where's the actual decimal in the problem? There it is. We're gonna make it nice and big. I'm glad you took it away. Yeah.
0.0027.
Gotcha. And how'd you know how to move the decimal 2 times?
Because whenever you multiply, you move the decimal 2 times or 3 times or 1 time
To the right.
to the right.
Uh-huh.
But whenever you move to the whenever you do divide,
Yeah.
you move the
Move it to
decimal
the
2
left.
times
That's
to the
exactly
left.
it. And Brianna, how many times did you have to move it?
Twice,
How do you know?
because there's 2 zeros and 100.
Brilliant! I love it. We have so much more to do. We're looking forward to do some more, but I know there's also some more problems to do back in the studio. So we'll head back there, soon to return to the home of the Mustangs.
All right, thanks for that, Scott. We will return there shortly. 636-4357 is the phone number. We do have phone tutors available until 5:30. In studio, we have Alyssa, a 5th grade student from Buena Vista. How long have you been a Bulldog?
Since 2nd grade.
Since 2nd grade. So you're pretty comfortable at Buena Vista?
Yeah.
All right. You're pretty comfortable in here right now?
Yeah.
All right, good. Back over to the board. Let's have you do some more work. So this time, I will let you come up with the whole fraction. So numerator and denominator, you come up with any fraction you like. Three sevenths plus, let's see, you are in 5th grade, so we'll go 5/6. So now, this is a little different, the next step from what you were just working on.
Okay, so we have different denominators, right? So let's go back to this real quick. You knew that 5 times 2 equals 10, okay? And we took that and we multiplied numerator and denominator to come up with 6/10, right? We also saw that we have 3 out of 5 here. We broke it into 10, right? And it also equals 6 out of 10, the same way. But here, does 7 go into 6?
No.
Does 6 go into 7?
No.
No. So what do you think we're going to need to think about here?
Multiply 7 and 6.
Let's try that. What is 7 times 6?
42.
42. Okay. So you know your denominator has to be what number?
42.
42. So what are we going to do to change each of these fractions so they both have a denominator of 42? What do you think you're going to need to do?
Multiply 3 by 6 and 7 by 5.
Why 3 by 6?
Because you multiply 7 by 6 and you have to do the same thing that you did to the denominator.
Very good. Go for it. And what did you multiply 5 by?
7.
Okay. So what's your next step?
You have to add.
Okay. Do you need to do some space over here? So walk me through this, what you're adding.
So I'm adding 18 and 35 together to get 53. And then
Where does that 53 go then? So we have an answer of 53 out of
42.
So here's my question. Your numerator is now larger than your denominator. Do you know what that means when your numerator is larger than your denominator? If I had 42 out of 42, what does that equal?
1.
Yeah, that equals 1 whole, correct? Because I have 42 pieces out of 42 equals 1 whole. But my numerator is larger than my denominator, so does that mean I have less than 1 or greater than 1?
Greater than 1.
I have greater than 1. That means I have more than 1. Do you know how to turn this to what's called a mixed number? Because this right now is called an improper fraction. It's improper because the numerator is larger than the denominator. So what we want to do, we can take this is correct, but we also want to turn it to a mixed number. The fraction bar, do you know it also means divide?
Yes.
I knew you knew that. So this really means 53 divided by
42.
42. So if we have to divide, do you think you could divide for me?
Yeah.
Okay, which one goes in the house?
53.
Got it.
And then 42 goes outside.
Yeah. 40, we're going to change that to a 2. So how many 42s go into 53?
1.
Okay. Oh, there you go.
42 times 1 is 42. When you subtract that, you get 11.
And we want a remainder here. We don't want to keep going with decimals. We want that remainder. So how many complete times do we have?
1.
Put a 1 for me, a big 1. What's my leftover? What's my remainder?
11.
And that's actually my new numerator. So let's put 11 as our new numerator. And my denominator is exactly the same. So we have, again, we need to change and find a common denominator, right?
Yes.
Add them up. And then if it's an improper fraction, we're going to divide those numbers to make it a mixed number. You rocked it. Good job.
Now, how can she be positive that that mixed number is actually the same as the improper fraction?
Do you know how to reverse it?
You multiply 42 by 1, and you get 42, and then you add it to 11, and you get 53.
Boom. There you go.
All right, nicely done right there, Alyssa. Great work. And for doing some great work right there, you've got a meal of your choice, courtesy of our friends at Grillenberger. So congratulations on that. Hopefully you have an opportunity to head on over there and say hi to Lydia. If you go to Grillenberger, say, hi Lydia, I'm Alyssa. I was on Do the Math. She'll know because you'll have the certificate, and she'll fix up a great meal for you. Sound good?
Yeah.
All right. Hey, we'll be back with more right after this. Today we're at Kernville Elementary School, home of the Mountaineers, and we're here to All right, back at Kernville Elementary School with some 4th and 5th grade students, and we've been doing some adding and then proving why 7 is a lucky number, right? But now we're going to do a little multiplying. You guys all know how to multiply, right?
Yeah.
You guys have all heard of 2 times 2 is 4, 2 times 3 is 6, right? You did all the multiplication tables. 5 times 5, 25, square numbers and things like that, all right? This is going to be a little different. So go ahead and take a look at the paper you've got, all right? So it says shape times shape. Now we see that we have a square times a square times a square is going to equal a half circle. Well, that doesn't make much sense right now, does it?
Nope.
But we know that the squares are all the same. So that means the number that a square represents must be the same. So try this, okay? If I went 2 times 2 is what?
4.
4 times 2
6.
is 8, right? Because I'm going to go on 4 times 2 is 8. You guys got the idea so far? Yeah. So if I say on my paper that a square is equal to 2, then what does a half circle have to be?
8.
8. Okay? Now I'm going to test it. Okay? If a half circle is 8, what does that half circle have to be?
8.
8. It has to be 8. Everybody with me?
Because 4 plus 4 equals 8, so it can't be a full circle, it has to be a half circle, because, yeah, right?
Could be. We'll find out, all right? Now, we know that a square is equal to what? 2. So if I say this is 2 and that's 8, what does that oval have to be?
6.
2 times what is 8?
4.
So we're going to say an oval is what?
4.
So on my paper, I'm going to draw an oval, and I'm going to put 4. Does that make sense to you guys?
Yeah.
Okay, so what I want you to do is on your papers, because you have a little bit of space on your paper down at the bottom, right? And we can go ahead and we can start like I did, right? So draw a little square, draw a symbol for a square, and you're going to put that a square is equal to 2. Do we all agree with that?
Yeah.
Right, we're all good with that. We also said that this little half circle, right, when we go 2 times 2 is 4 times 2 is 8. So we all agree that the half circle is 8. Right? So that satisfies this first equation. Even though there are no numbers, we appointed numbers to those different figures. We know that the half circle is 8. We know the circle is 2, so 2 times 4. So we know the little oval is 4. All right, so you can make an oval and put equals 4. All right? So now, here's what we're going to do. We're going to see how far you can get. Okay, because we've done these so far. Okay? So now, you want to look and test it. Okay, because the way we started doesn't mean that it's already correct. It works so far, right? But doesn't mean it's perfectly correct.
No.
It may not be, right? We can only know if we keep testing.
I think I know what the circle is.
You think?
Yeah.
What do you think?
16.
Well, I want you guys to go ahead and try them. Okay? On your paper, just see if you can kind of start figuring out what the other shapes are equal to. All right? You can work together, you can work individually, however you want to work on this, all right? So go ahead and give it a try. Anybody have an idea on some of the other shapes, what they might be? Because this is really, you're trying to think a lot about what can you do to make these work.
I think the square could be 2 because 2 times whatever that is can't be that same number again. Whatever that is, unless it's a 0.
Could we have a 0?
Yes.
Is 0 a number?
Yes.
It could work, right?
But when you multiply anything by 0, it's 0.
Well, take a look at the one he was talking about, right? Because if we go 2 times 0, what is that going to equal? 0. So that would work, right? Here's what I want you to do. Take the blue rectangle and make it a 3.
So the circle could be.
If the blue rectangle is 3, what is a red circle worth?
12.
12. You guys all get it? All right, there you go. Learning, this is the first step to algebra. Instead of taking shapes, you're going to be taking letters that are going to represent numbers. A little bit more math with the students at Kernville Elementary School. Great students to work with at Kernville Elementary School right there. We have Alyssa in studio with us, a 5th grader from Buena Vista. Right now we have another opportunity to head on out to visit the Mustangs of Miller Elementary School.
Hey, we are back here at Miller Elementary School, home of the Mustangs, and we are interested in doing a little bit more math on these whiteboards because this crew that we have today, super solid. Here's what we're going to do today, crew. The next part that I really think that is kind of a fun way to do it, we saw some shortcuts with multiplying and dividing by really big numbers that end in 0, okay? The other part is sometimes we can bring in English into math, right? We can bring in reading into math. So for instance, I wrote this problem here on the board. The sum of 32 and 147. You are going to translate this problem. This problem is written in English. It's written in words, almost like a sentence. I need you to translate this problem into math, okay? Do the best that you can, and then come up with an answer, of course. But I'm going to ask you, hopefully in a moment, to explain to me how you knew what to do. I know that earlier we got a chance to look at this table, and we got a chance to look over here. Chad, how'd you know how to do this problem, man?
Because the sum
The sum?
Yeah.
The sum means what?
The answer.
Okay. Yeah, it does mean the answer. The answer to what kind of problem, though?
The math problem.
It is a math problem. Specifically, give me an operation. What does sum refer to? Addition. There you go. That's the important part, right?
Added 147 and 32 and
Good.
got 179.
Okay. Gotcha. Any commas necessary here?
No.
No? Anybody else get anything different that they want to go ahead and show me that is different than what happened there? The sum is the important word there, right? Okay, so you can keep the numbers on your board. Keep the exact same numbers that you have there, okay? And all I want you to do is we're going to change that word sum, S-U-M, to the word difference, okay? And so the sentence would read, we want to know about the difference between 32 and 147. Now I'm really interested to see what you will do, because there could be more than one answer to this problem. Brooklyn, what do you got?
I did 147 minus 32 equals 115.
So how'd you know the minus?
Because difference is equivalent to subtraction.
Difference is subtraction. There you go. So you did 147 and 32, and you got 115. Anybody else get something different than 115? Oh, we have consensus here. And I noticed that most people, when we did the sum, put the bigger number on the top and the smaller number on the bottom. Look at our sentence again on the board, okay? And on the board it says we want to know the difference of 32 and 147, right? If you put those in the exact order that it's written, wouldn't 32 be on top? 32 and 147. So write down this problem real quick, all right? If you need to, next to it, you can leave what you have or you can erase it. 32 on top, 147 on the bottom. So the problem now is 32 minus 147. What in the world are you going to do with that? Here's what I'm going to do. I'm going to give you 30 seconds. I want you to talk with your group, because maybe this is a problem you haven't seen before. Maybe you want to talk about it a little bit and see if you can come up with an answer. What's going to happen? Is it the same answer it was before, or is it going to be different? My guess is maybe different. So talk about it with people around you before you come up with an answer. Just about 30 seconds.
Different because if 32 is on top, it's gonna be different because it won't have 3 digits.
Okay.
What did you get?
Take about 10 more seconds. Think about it a little bit. Okay, if you were given a problem that said difference in it, first of all, it seems like we all know it's going to be a subtraction problem. Great job, okay? And if the problem was written like I've written it here on the board, the difference between 32 and 147, you'd have 119 like you had before. However, if you translated this directly, right? In other words, if it said 32 minus 147, and you put the 32 on top and 147 on the bottom, tell me what kind of answers that we have come up with that may be different than what we had before, okay? Okay, what do we have here? Interesting. I like it. So this was the addition problem. This was the subtraction problem. And now we're changing things up a little bit. Over here we have 85. Wow. How'd you come up with 85?
Because you minus 2, you can't minus 2 from 7, so you have to borrow.
So you borrowed,
so
yeah.
12 minus 7 equals 5. And then you can't borrow from, you can't minus 3 from 4, so you have to borrow again. And then you can't do 13 because you've already done it more than one time, so it's 12, and then minus 4, and I got 8.
You got the 8, gotcha. And it looks like you tried to borrow from down here because there wasn't anything to borrow there, huh? This is why this problem ends up being really interesting, I think. Ends up being an interesting problem. Okay, what about over here? Oh, you still have 115. Tell us about that one. How did you get 115 still?
Because I did it a different way. Instead, I didn't borrow, so I got 115.
Okay, you still got 115. All right. And over here, Jack got 115, but he put a negative in front of it. Why'd you put a negative in front of it?
Because usually whenever you have this, it's usually a negative. And
Why?
Plus, because
These are tough questions, aren't they?
I can't really explain it. But
That's kinda rough,
32
yeah.
minus 147 probably is lower than 0, which is 8.
Ah, it's lower than 0.
So-
That's kind of a good idea.
But
So let's talk about that a little bit. When we come back, we'll be able to figure out which of these 3, maybe even some more answers, which of them is actually the correct solution of this problem. The thinking is going on, the wheels are turning, and we know there's some more to do back in the studio, so we'll head there, but back to see what the official answer is when we return.
All right, thanks for that, Scott. Right now in studio we have Alyssa, and Alyssa was working on some fractions earlier, and you feel pretty good with those, right?
Yeah.
So in 5th grade, you're going to do a lot of fractions, decimals, and percents. And you said that you're kind of familiar with decimals right now, right?
Yeah.
And you're multiplying and dividing them, or just one or the other?
Both.
Both. All right, well, what would you like to do first, multiply or divide decimals?
Divide this.
Divide decimals? All right, hot shot over to the board and let's see what you've got. Do you want to come up with the problem?
No.
You want Mary Lou to come up with one? All right.
Okay, you ready?
Yeah.
Okay, so are you dividing decimal by decimal or decimal by whole number?
Decimal by whole number.
Decimal by whole number. Okay, so let's do this. There you go. So walk me through it, what you're going to do.
So first you have to rewrite it, and then 3 can go into 6 2 times. So you put 2 right there, and then you multiply 3 times 2, and you get 6, and then you subtract, and you get 0, and then you bring the 4 down. 3 can go into 4 1 time, so you multiply 3 times 1, which is 3, and then you subtract, and you get 1. And so you bring the 2 down, and then 3 goes into 12 4 times. So 3 times 4 is 12. And then you subtract, and then your remainder is 0, but you still have to put the decimal.
Thank you. That's what I was waiting for, the decimal. Now, why don't we move the decimal? Why does it stay put?
Because if you move it, then you'll have a completely different answer.
And it also stays put because you're dividing by a whole number. Okay? You ready to see when you have to move the decimal?
Yeah.
Okay, there we go. So let me think. So, do you think that we're going to be dividing the same way that you just did?
No.
Actually, we are. There's only one step that we need to add. With decimals, this is our dividend, this is our divisor, okay? When we're dividing, our divisor always needs to be a whole number. How can I make that a whole number? What do I need to multiply this by to make it a whole number?
5.
Not by 5, to make it a whole number.
0.5.
Actually, did you do the powers of 10 yet?
Yeah.
Think powers of 10. So it's going to be 10 to the what power to make it a whole number? How many times am I going to move that decimal over to make it a whole number?
1.
So I'm really multiplying this just by 10, right? If I multiply this by 10, am I going to get 2? Yeah, right? Because we're moving the decimal over 1. What I do to the divisor, I have to do to the dividend. So if I multiply this by 10, what's my new decimal? Now are you ready to divide?
Yes.
There you go. See, dividing with a decimal as your divisor, you just have one more step. Are you still dividing now exactly how you did?
Yes.
Okay, go for it. Solve it.
So first you have to rewrite. 2 goes into 7 3 times. 2 times 3 is 6. Then you subtract, and you get 1. Bring the 4 down. 2 goes into 14 7 times. 2 times 7 is 14. You subtract, and then you get 0. And then you bring the 6 down. And then 2 goes into 6 3 times. 2 times 3 is 6. Subtract, and you get 0. So you have remainder 0, and you still need your decimal.
Okay, so we want to make sure we come up with the exact same answer, right? So over here, I want you to double check your work, and I'd like you to multiply 37 and 3/10, right?
Yes.
Multiply it by 2 and tell me what happens. Okay, so we ended up with a 74 and 6/10. Yes?
Nicely done.
There you go.
All right, I've got another problem for you to work on. Has nothing to do with fractions or decimals. So, Alyssa, have you ever heard of the order of operations?
Yes.
Yeah?
That was a little, yeah.
All right, here we go. Mary Lou, write the problem on the board.
Okay.
We have 5 plus 5
Oh no.
divided by 5
Oh no.
plus 5 times 5 minus 5.
All of the operations with the 5s.
There we go.
You ready? Okay, order of operations, PEMDAS, right? Please excuse my dear Aunt Sally why we don't know. But are there any parentheses?
No.
Can you create your own parentheses?
Yes.
Yes. The E means exponents. Are there any exponents?
No.
No. Is there multiplying or dividing?
Multiplying and dividing.
Okay, remember, it's whatever comes
First.
So, what's coming first? Dividing or multiplying?
Multiplying.
Look again.
Dividing.
Dividing. Can you put parentheses around that?
Yes.
Can we do this? Is there a rule that says we can't do that?
No.
No, we can't. So, is there multiplying?
Yes.
Okay. So, let's take care of those first. Okay, rewrite it for me now. What do we have left? There you go. Okay, so now we're at adding and subtracting. Do we always add before we subtract? Or is it the same rule as multiplying and dividing?
Same rule.
Okay, so we're going to go from left to
Right. So, plus 1 is 6, plus 25 minus 5.
Are we going to go 25 minus 5, or are we going to go 6 plus 25?
It'll still work.
Will it still work? Okay, go for it.
That's 20. And then when you add that, you get 26.
There you go.
All right, hot shot. Erase the correct answer that you've gotten down at the bottom. So erase those 2 lines that you did.
These right here?
Yeah, so erase the whole 2 lines. Everything that she's done so far, just get rid of it all.
Oh, okay. All this down here.
Right, leave the original problem up there.
All right. And then do you want me to take...
Get rid of the parentheses.
Okay, you erase yours.
So I'm going to give you 2 minutes, Alyssa. What I'd like you to do is I would like you to show us how somebody could have come up with 30 instead of 26 for that answer.
What do you think? How did they come up with 30?
So you can just write 30 off on the side so you remember that's what you're supposed to get. But you've got 2 minutes to tell us how they got 30.
Okay. What do you think? Where's the mistake? If they came up with 30, they made a mistake somewhere. So where do you think they made a mistake first?
Maybe they just started adding like doing the equation like that.
Okay,
So 5 plus 5 is 10 divided by 5.
Okay.
and then plus 5. Wait,
Yeah, it's easier just to rewrite it if that's what you want to do.
What's 10 divided by 5?
2.
Okay. Now you're going to bring down your plus 5.
It's 5
And we're at times 5.
times 5
Minus 5.
minus 5.
Okay.
So 2 plus 25 minus 5.
Okay. I'm going to take that off right there. Okay, so what's 2 plus 5?
7.
I'm sorry, 2 plus 25.
27.
27. But 27 minus 5, does that get us 30?
No.
No.
So leave
Okay.
your line before that.
So we're going to,
So that first line, 2 plus 5 times 5 minus 5 is fine.
okay, so this is fine.
So keep doing what you were doing, just
Got it.
going in order.
So let's think this way. If we do, what's 2 plus 5?
7.
2 plus 5 is 7. 7 times 5 minus 5. What does that come out to be?
30.
What?
30.
There you go. Boom.
Because there's going to be times when you have problems like that, and 30 will be an answer, and that's how some students may come up with it,
Yes.
by just going all the way straight across with that. So nicely done. Congratulations, you've got yourself a couple of tickets to go see the Bakersfield Condors. So we hope you have an opportunity to go enjoy that. And we do have one more opportunity to head on out to Miller Elementary and visit with the Mustangs.
Hey, we're back here. Thanks again for drawing it back here to the home of the Mustangs here at Miller Elementary. We had some discussion last time about, not quite sure what the answer is, not quite sure what the sign is. So we talked a little bit about that during our time away from the studio. And we came up with this problem here, and I think that through working this problem, we can probably figure out and have a picture of what's going on. This problem is positive 46 minus 89. And without a lot of knowledge of positive, negative numbers, I know that this crew can do it. Show me what's going on here. I want to see a picture. I'm going to come around the side here because I know that we've seen some amazing things from this side. I want to come down here to this crew. We have a picture of what's going on. We do need a number answer. Okay. JC, what's going on, man? What do you got?
So for the positive, I put like a C, and for a positive, it goes up. So I put the pointers up, and I put that as 46. And
Good.
then for negative, I put it down, and I put it as 89.
Right. And some of those things are going to cancel out, right? So we have a great picture going on there. Let's see if we can do some math with it. Who's got some math that can show us with a picture and what's going on here? Really? No? I love your picture, though. I love what you're looking at. Show us this part, even though you don't have an answer, okay? You got 46 minus 89, and this is the exact problem that we want to do, right? This is the exact problem that we want to do. But we got to figure out how we're going to do this problem because you can't start borrowing. There's not enough numbers, right? Now tell me one more thing. You have a number over here that says 43. Why do you have this 43 here? I love that. This is a wonderful answer to have, a number to have. But where did it come from?
You do 89 minus 46 because
you
that's
switched
what
it
you
around to
have
do the way
left.
you could do it. Yeah, great idea. I like it.
Left is gonna be
Wonderful. Hold on to that idea, okay? Hold on. Don't erase that because that's a wonderful job. Anybody else get something? Oh, Angel. I don't have a picture from you, but I have some wonderful numbers. Tell me a little bit about how you came about doing this problem here.
So since 46 can't go into 89, I flipped it over and subtracted that.
Okay.
And since like it couldn't, it needed to go to like the negative numbers.
Yeah.
So I put 89 on top and 46 on the bottom, and then my answer I put a negative on it. So I got
A negative in the front of it because that bigger number was negative, huh? Who's got a picture of negative 43? Over here. So we have 89, we got 46. I see you trying to do some borrowing there. We definitely have a negative here, and we want to work on these numbers here. I like what you did here, but it is so hard to subtract a bigger number from a smaller number, right? So I really like what you did, the effort here. We definitely know it's negative. We definitely know it's underneath the water, but I think we're going to go back here to negative 43. We're going to go up a little bit and all the way down to 43. This is a good picture of what's going on here, negative 43. I like it. And in these groups, it's such a wonderful opportunity for you to see what's going on around you and see what's going on. Negative 43 is what we're shooting for, right? And the picture goes up 46, and then from there all the way back down 89. And so if you started in the middle, you're definitely going to be in the negative part. So make sure you have a negative in front of it. All right, we're going to change gear just a little bit because I know that some of you want to do some algebra. A couple of you said that maybe you've done some algebra before, and a couple of you said maybe you haven't. So we'll do a couple of really simple algebra problems, okay? And instead of using some letters to throw people off, if you haven't seen algebra before, here's all it means, okay? Triangle. What? Some number is going to go in this triangle. I don't know what it is. But if you add to that triangle 31, your final answer, okay, some number in the world that we don't know, plus 31, your final answer is 100, okay? We want to know what goes in that triangle. Now, there's probably about 17 ways for you to explain this to me, and I want you to use one of them. So show me on your board, but explain to me how you came about it. How do you know what to do there? What's going on there? Looks like it's an addition problem like we did before, but I have a tendency to think that maybe some of you are going to use something other than addition. Giselle, what do you got going on here?
I'm subtracting 100 from 31.
You are subtracting. Now, why in the world are you subtracting when this says triangle plus 31?
Because if I subtract 100 from 31, I'll get my answer.
Because you're looking for the pieces missing, right? Yeah, I like it. Okay, keep going. Don't let me throw you off too much. I'm going to swing back around over here. I know Jack always has something going on. Jack, tell us what happened here.
Okay, so I got 31 and the triangle equals 69.
Why? How do you know that?
Because I tried to solve this and I'm like, well, if I do that.
Oh, you
what
did a
would do
little bit
that?
of trial and error. That's a wonderful idea.
So I did this, which would add to that. So I'm like, okay,
Oh.
so 6, that would be 9 plus 1 or.
What a great idea. A little trial and error. That's a good way to start some algebra. Anybody else have a different way of going on here? What else happened here? How'd this number come about? I like it. Where'd it come from, JC?
So I was doing mental math, and I thought, and I was thinking of doing 70, but that would be 700. That would be 101.
Mm-hmm.
So I thought using 69, because 6 plus 3 equals 9, then 9 plus 1 equals 10, and then put that with the 9, and then you get 100.
That's it. There you go. So no matter where you are in your path towards algebra, and it's coming, whether you're excited or not, you might as well be excited because it's coming. No matter where you are in your path, I can see that you have some skills to be successful. A couple skills that you're going to need are some trial and error that I've seen already, right? Some translation between words to numbers, and also to be able to communicate with the people around you to see, hey, this is what I got, what do you got, which one do you think is right, to do some error analysis to be able to figure out who's right and who's wrong. So much good stuff going on here. We know there's more stuff going on in the studio. We want to go ahead and say thank you to this crew here for allowing us to come and join them here at Miller Elementary. But right now, back to the studio. I know there's more work to do there as well.
All right, thanks for that, Scott, and thank you to the students over at Miller Elementary and their ACES after-school program. We do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. In studio, we would also like to thank Alyssa, a 5th grade student from Buena Vista. Worked on fractions today, decimals, and order of operations. You ready to do some more?
Yeah.
Oh, well, maybe you can another time because we're just about out of time. Did you have fun today?
Yeah.
All right, very good. That's exactly what we want. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.